Okay, so in this video we're going to look at converting a decimal floating point number into its binary equivalent, but we're going to deal with the negative numbers or the smaller numbers that you might get as well. So let's say we've got a positive number, say 0.375, and we want to convert that into its binary floating point equivalent. Well, if we write it out first of all, and it's going to be not a half, it's going to be a quarter and an eighth is how that will be written out. So thinking about this, what we want to do with normalization is we want to move the decimal place to a normalized position. Now this isn't normalized because it begins 0.0, and any normalized number will begin 0.1 that is positive. So this actually needs to move one place to the right hand side. So if we take this number and we've moved it one place to the right side, the final mantissa is actually going to be really straightforward. It's going to be 0.11 and then it's going to be remainder of zeros. Now the slightly odd one is that we now need to convert the exponent. So the exponent has been shifted by one place. So if we're going to write this out, 1, 2, 3, 4, 5, 6, but actually it is a negative value because it's going to be -1, so we need to perform 2's complement on this. So starting from the right hand side, least significant bit as always is going to be remain the same, and then we're going to convert everything else to the corresponding value. So in actual fact the exponent is going to look something like that, because when it's switched round, 0s to 1s, 1s to 0s, that will give us an exponent of -1. So I'm going to give you one to try now. So that's converting when you've got a small positive value, okay? And the small positive value I'm going to get you to work with this time is I want you to look at, in fact, no, sorry, hang on. I would like you to look at 0. 0.5, a quarter, an eighth. I'm making one up off the top of my head here. Let's go with 0.0625. Okay, so have a go at doing that now, and then we'll compare answers in a moment. Okay, so 0.0625, we write this out. I'm just going to put a few zeros in front of it, and it's going to be half, a quarter, eighth, and 16, so that's 0.5, yeah, there we go, that's 0.0625, and we want this to be normalized, so we're going to move this over by 1, 2, and 3 positions. So our final mantissa is going to be 0.1, and then a corresponding set of zeros. And our exponent is 1, 2, 3 places, so we're going to write that out as 1, 2, 3, 4, 5, 6. But because this is going to be -3, we need to then do the the 2's complement conversion. So that's everything up to and including the first one. So that's going to remain the same, but then that one will change, and like so. So that gives us a value of -3. So that is how to do conversions for small positive binary numbers.